This is going to be the fifth rule of differentiation, usually called the chain rule. So in this series, we are looking at the last rule of differentiation, and this is also referred to as function of function. And it says that if y is equals to f of u, where u is a function of x, then dy over dx will be equal to du dx times dy du. Similar formula with your power rule. Makes it different. For power rule, we have a complex base and a constant power. Okay? But for chain rule, we have a function of a function. What do we mean by function of a function? For instance, a regular exponential function is exponential x. This is the basic. For logarithm is log x, ln x. We also have log x, log to base anything of x. Okay? For trigonometry, we have sin x, we have cos x, we have tan x, sec x, cosec x, and the rest of them. Okay? So whenever this x you are seeing here, all these x become replaced by a complex function of x, by a function of x that is not an ordinary x, it becomes a chain. So for instance, if I have exponential 3x squared, since it's not an ordinary x, this has become a chain. The power is a chain. If I have ln 2x squared minus 3, instead of an ordinary x, it's now a function of x. This is a chain. I can have sine, let's say ln x. Instead of sin x, I'm having sine ln x. This is a function of function, and so on and so forth. So whenever the x in a basic function is replaced by a more complex function of x, you have a chain. And whenever you have a problem involving a chain, you can solve it using the chain rule. So let's look at some examples. So let's use this as our first example for chain rule. We are given that y is equals to exponential 3x squared plus 2. So as we've said, since our basic form for exponential function is exponential x, and the x has been replaced by a complex function, this is a chain. So in chain rule, we say let the u be the chain. Our formula remains dy over dx equal to du dx times dy du. So we are going to say let u be the chain, 3x squared plus 4, which means whatever function is replacing our x in the basic form is the chain. Differentiate your chain. You have du dx, which is 6x. 4 is 0. You let it go. Then this implies that our y is now exponential u. So if we differentiate y with respect to u, it remains the same. Remember, exponential x is exponential x. So exponential u will be exponential u from our table. So now we substitute into the formula. Therefore, dy over dx is equal to du dx, that's 6x, times dy du, that's exponential u, which means we have 6x exponential u. And when you bring back your u, you have 6x exponential 3x squared plus 4. So this is our chain rule. Okay, this is our second question for chain rule. It says you find dy dx if y is cos 5x. So what's the chain? What has replaced our x in the basic form? 5x. Okay, so that's our u. So I can come here, our formula says dy over dx is du dx times dy du. So let u be the chain. Differentiate the chain. Remember ax will give us a. So this means that y is now cos u. Replace the chain with u. Differentiate y with respect to u. If you differentiate cos, it normally gives us minus sine from our differential table. So with this now, we can substitute into the formula. So dy over dx is equals to du dx 5 times dy du minus sine u. When you multiply, you have minus 5 sine u. What is your u? Minus 5 sine 5x, because our u is 5x. So that's our answer in the second question. Let's take one more question. Okay, our next question says we should find dy dx if y is ln sine x. Instead of our usual ln x, our x have been replaced by sine x. So our chain is sine x. So let's go. The formula remains dy over dx equals to du over dx times dy over du. Take note, this formula is always written in such a way that du can cancel out and you have dy dx left. Okay, in case you are missing the formula, that can help you check it. So now, what is our chain? Our chain is sine x. When you differentiate the chain, du dx, what do you have? Cos x. This implies that y is what now? Ln u. When you differentiate ln, what do you have? Dy du. That's 1 over u. Remember, when you differentiate ln x, is 1 over x. So ln u will be 1 over u. So if we put them together in the formula, we have dy over dx to be equals to du dx cos x times dy du 1 over u. So this is equals to cos x over u. What is u? U is sine x. So we have cos x over sine x. And cos over sine in trigonometry is cot. So that's the final answer. So this takes us to the end of the 5 basic rules of differentiation. Every other problem we'll be solving in differentiation will be based on this rule. Thank you for following us to the end of the series. In case you are yet to subscribe, please subscribe, comment, and share this channel. I believe you'll be helping a lot of people as you do that. Thank you. Have a wonderful day.